Properties of logarithms. We are going to move between what we call our condensed logarithm to our expanded logarithm. If you look at the left-hand side of the equal sign in the properties of logarithms, this is what we call our condensed, and that's where you'll see one logarithm. With our expanded, you could potentially see more than one logarithm. Now there's a relationship between logarithms and exponentials. They are inverses of each other. There is also some overlap that you might see between the properties of exponents that we've investigated in the past and the properties of logarithms. So if we just look at the very first property, I'm going to write down the exponential property that is similar so you can maybe see the overlap and make connection. On the right hand side, I've written the exponential property where when you have bases that are the same and you go from expanded version to condensed version, you have bases that are the same with a multiplication between the bases, you add the exponents. So there's a direct relationship between multiplication and addition. If you look at the logarithm, on the left-hand side, you see a multiplication between m and n, and then on the right-hand side, when it's expanded, it changes into two different logarithms with an addition sign in between. With the next quotient property, there is a relationship between division and subtraction, the same as with our exponential properties. On the left-hand side with the condensed version, you see a division. On the right-hand side, it's split into two logarithms with the m and a subtraction before the n. Notice that, and this is important, the n is second and is after the subtraction sign. The last property is our power property, and that's when we have an exponent, and what we do is we take that exponent and we bring it to the front of the logarithm and it becomes a multiplication. I've added two additional properties in here, and that's our inverse properties. We've talked about one of them in a previous video, and that's when we see a base the same as that number that follows it, then they can be simplified and canceled, and what's left over is whatever the exponent is as the solution. What I haven't talked about is the reverse of that, where we start with an exponential, and that's our b, that base of the exponential, and in the exponent is a logarithm. Those can also be simplified to 1, and whatever that number is that left over is our solution. So both of these are properties that are necessary to know as well. They're called inverse properties because if you look closely, you'll see that there is a logarithm and an exponential put together, and because they are inverses of each other, they cancel each other out. In the second one, we have the exponential first and then the logarithm, so therefore they cancel each other out, just leaving this x in this case as the solution. Now let's get to some problems. This question is asking us to expand. So we're going to go from 1 logarithm base 5 to more than 1 logarithm base 5. Now between the a and b, there is an implied multiplication. If it's easier to see this, you can actually write it out. That means that we're going to change this into two different logarithms. Both logarithms remain with a base of 5, and we put an addition sign in between. So this is our product property of logarithms. Then we are not finished yet because we can take the exponents and bring them to the front of the logarithm. So that's our last step. So 2 log base 5 of A plus 7 log base 5 of B. And this is using our power property of logarithms. And this is our final expanded answer. The next example is asking us to expand as well. Now notice here we have the natural logarithm. That is a logarithm. It's just a special case. So we will continue to use that natural logarithm. So we will separate this using our quotient property. So we'll take that natural logarithm of 25 and we will subtract the natural logarithm of 3. And that is our final answer. Now we're going to change into a single logarithm or condensed. So you'll see that we start with 3 logarithms here. The first thing we're going to do is apply our power property. So we're going to take that multiplier in front and it's going to become an exponent. So we get log base 4 of m to the 4th plus log base 4 of n to the 3rd minus log base 4 of p. Then we're going to use our product property. And our product property means that we can take the m to the 4th and n to the 3rd. We can put these two logarithms together as one, and they will now be multiplied next to each other. And then the last thing that we're going to do is use our quotient property. So when we have that subtraction, that means that the p is going to end up being in the denominator. So we write this as one final logarithm with m to the 4th n cubed over p. And this is our final answer. We'll do the same thing but with our natural logarithm. We'll start by using the power property. So we'll take the multiplier that's in front and it will become the exponent. We can actually simplify and change this to the natural logarithm of 8 minus the natural logarithm of 25. Then we have a subtraction, so we will use the quotient property. So it reduces to one single logarithm of 8 over 25. And that's our final answer.